Hi everyone, great to meet you all. My name is Xiao from Chinese animation studio called Nice Spot Animation. I'm a 3D artist and art designer. This is my colleague Jinze. He is a technical artist in our studio. Today, we'll be presenting together. This is our first time in Europe, so it's normal that you don't know us yet. But maybe, just maybe, you feel that the add-ons release some blend extensions of GitHub, like simple deform hyper, police hyper, bbrush, property, jet hyper, and colorista. Over the past 5 years, we've been making TV animations with Blender, and this time coding to solve the problems we run into during the production. Just this month, we wrap up production of the TV animation. We thought this was a perfect time to share. In detail, what our team went through over these 5 years, how we used Blender to make the TV animation deep dive for the event, how we tackled all kinds of challenges, and we hope this can help individuals or teams who want to use Blender. Let's take a look at the trailer.
阿祖，意识读写技术真的来自月亮。
亲眼目睹，如果这个技术继续被约瑟垄断，人类就完蛋了。
李海拉，王二记，出动！
被碾碎过的蝼蚁，还想逆转什么呢？继续活在幻想里吧。
小啰嗦！反正我的意识也被重置过无数次了。
喂！约森不仅要霸占你们的肉体，还想要夺走你们的灵魂。现在我们已经掌握了能够向约森复仇的力量，你们也是这股力量的一份子。
根本没人需要你们去反抗约森，灵境会让人们从现实的痛苦中解脱。大家都巴不得早点进入灵境，谁跟约森作对，谁就是大家眼中的反派。
所以你做的事情和约森有什么区别？
想和恶魔进行对抗，那就必须使用和恶魔一样的力量。
不用你说我也知道，你们约森的报应就要来了。
Like every team starting new projects, we face a question that almost every Blender user has wrestled with. Should we use Blender as our main production tool? I bet if we gathered all the reasons creators around the world have chosen Blender over the past 20 years, we could fill a very thick book. First, the reason is simple. We want to use Blender to completely change how 2D and 3D terms collaborate. Let's go back to 2019. We decided to make a sci-fi animation. Back then, our studio got its start with 2D animation. We're good at that like this. We also made some 3D animation, and we combined 2D and 3D to go 3D animation, a more stylized look. Logically, we should have stuck with the old folk flow. But we didn't want to keep in tight to closed software anymore. We also want 2D 3D combination to go smoother. Plus, we have some wild idea for animation software. We want to invent new tools. Those ideas are allowed to use in open source software like Blender. So our dear Jinze made this concept trailer entirely in Blender 2.9 to test our idea. Clearly, Blend's more than capable of handling for professional animation production. Then we got the contract to make the animation. And in 5 years, we took a bit longer on the script, but we finally finished it. Next, my colleague Jinze will show more details.
Thank you. Let me take a breath. Okay. Hi everyone, my name is Jinze, and I work as a technical artist on the Deep Dive project at Niceboat Animation. It's a great honor to be here today to share the outcomes of our work with all of you. As mentioned earlier, the first trailer you just see before for Deep Dive was created by our lead director, Jinze, himself using Blender. However, unlike individual creation needs, a production pipeline suitable for team collaboration and supporting tools are essential for scaling up our work in the future. I joined the team during this time in 2022, and together with several colleagues, we built the Blender production pipeline specifically for Deep Dive. We tested and refined this pipeline during the production of the second trailer before officially rolling it out for the project's main production phase. During the pipeline development, we referred to numerous blogs from Blender Studio. And here we would also like to extend our sincere gratitude to Blender Studio for sharing such a wealth of valuable information. So next, let's walk through the pipeline and show you how we utilize Blender in the production of Deep Dive. Let's first start with the asset pipeline. Assets are graded by levels. High-level assets go through every stage of the asset pipeline, while low-levels ones skip certain steps to save time. We determine an asset level primarily based on the number of scenes it appears in and the specific shot requirements. Each level has distinct specifications, including polygon count limits, texture density, number of building tiles, rigging completeness, and the weather hair and the cloth dynamic effects. Once assets are graded, we can begin their actual production. Let's start with the character segment. Deep Dive features a large cast of characters. The image on the slide is a lineup of the main characters from the early stages of the project, and many more have been added as the project has progressed. Considering we are a small team of just over a dozen people, to speed up production, we designed the pipeline to maximizing parallelization of its phases and getting assets into the layout phase as quickly as possible and ensuring assets are easy to iterate on and adjust later down the line. This is a simplified flowchart of the asset pipeline, and we will introduce how we use Blender in the project following this order. Here's the theme. At the start of a project, we only have early concept art, and once storyboards are done, we need to jump into layout work as quickly as possible. That's why we need a way to build and adjust the characters' models fast. So here's our solution. We use basic geometric shapes to block out characters, and these simple shape-based models need to match the proportion from the concept art. Like you see on the top left corner, the blocked out characters are pretty the same to the early stage of the concept art. They will act as a reference for the final design in later stages. Once the blockout is done, we use Rigify's default settings to rig them up quickly. We call these pre-assets. Having these pre-assets let us split the work. A part of the team can start layout right away, while another part of the team can begin the full asset pipeline using the pre-assets as a foundation. This way, we keep production moving forward with less delays. The modeling phase is primarily divided into two steps, a high poly stage and a low poly stage. To facilitate subsequent rigging work, all character bodies share a single topology, and essential attributes such as UVs, weights, and face groups are established on this base mesh. The high poly phase mainly utilizes sculpting tools and other utilities to finalize the model in accordance with the final concept design. The low poly phase involves retopologizing the high poly model, and the mesh hair and the clothes are also created during this phase. Mesh hair primarily defines the hair groupings and the silhouette shapes, and serves as a preview for the animation. Additionally, we also create a proxy model to improve viewport playback performance. Once the model is complete, it moves into the rigging phase. Since the rigs for the pre-assets aren't compatible with those for the final assets, we prioritize getting the subsequent layout work using rigs that are compatible with the final ones. This allows the animation phase to directly import assets and animation data from layout, streamlining the start of the animation work. We call this basic rig the base rig, and refer to it as B-rig in our workflow. To speed up the creation of B-rigs, we modify the default human rigify meta rig. It primarily incorporates more automation features for the face, along with additional bones for shape refinement, like the joint on the elbow and the fingers. Around this meta rig, we've also built an add-on that handles retargeting primarily based on vertex groups. Because after the adjustment of the face, there are many small bones added on the default one. If you retarget them manually, it's very time-consuming. So here's a quick demonstration of how it works. Here's a character's body and an unmatched meta rig. We already set the meta rig as a target armature, so we can match the armature by a single click. We can see the meta rig is now matched. Click the generator button, we will get the initial base rig set up. And like this. Then we can check the base rig by applying some preset actions. Like this. And then you have the basic setup and the facial actions. That's in some clicks. And next one. When it comes to non-human characters, primarily robots, we still stick with Rigify. We will manually build the mechanics if there's no exist Rigify type can directly generate. Staying within the Rigify brings 3 key advantages which streamline our workflow significantly. The first is, for Rigify to work as intended, you need to follow some specific naming conventions and bone structure rules. This makes the whole rigging process more organized, especially dealing with complex rigs. Second, Rigify conveniently generates control bone shapes and rigging UIs automatically. We don't have to build these essential interaction elements from scratch, which saves us a considerable amount of time during the production. Third, Rigify supports post-processing of the final rig using custom scripts. For example, if there are constraints or drivers that are cumbersome to set up directly in the meta rig, we can easily add them after the rig is generated using these post-processing scripts. Once the rig phase is complete, this asset is ready to update to the AST file, AST, which I will explain later, and move on to the layout stage. The UV creation workflow is relatively straightforward, just a good old UV unwrapping and packing. We will use existing add-ons to help speed up the workflow, like text tools, UV toolkit, and UV packmaster, like that. And the next, the groom, material, and the rig phase will start at the same time. Among these 3, the material phase is essential, but for groom and the rig, whether we need to know to work on them depends on 2 things: the character's design, and the priority level of assets. Like robots, you don't need to do first on them. Most of the robots have no first. Okay, and first, let's talk about the groom process. We use hair curves and geometry nodes to build our character's hair, along with the basic hair materials. Generating hair via geometry nodes is pretty CPU intensive, so to keep animation playback performance from dropping too much, once the hair is finalized, we'll apply the geometry nodes modifiers to the hair. We'll also retain key attributes, like the guide curve index, which is essential for hair simulation later, because you need to know which hair to guide the whole simulation. Every character's hairstyle varies a lot, so most of the time we have to create hairstyles manually. But for features with limited variation, like eyebrows and eyelashes, we built a small add-on. We paired this add-on with geometry nodes to generate eyebrows and eyelashes quickly. And here's a quick demo of how that works. The add-on will generate eyelashes based on vertex groups. We can select edge loops where eyelashes grow and assign them to the target vertex group. The eyelashes will generate immediately. We can do further tweaks using geometry nodes like this. We can use all the parameters and float curves to tweak the shape of the eyelash. So we can use this approach to quickly get the base shape of all the eyelash and eyebrows. And eyebrows are pretty the same. Select edge loops you want to grow, assign a target vertex group, then you tweak using geometry nodes. The eyebrows has more options to tweak, like the density variation, silhouette, the upper one and the lower one, and you can change the tilt along the eyebrow and the band direction, like this. You can make most of the eyebrows and eyelashes using this combination of geometry node and the small add-on we built. And here's a clump. So next is the material. Once enter the material phase, we'll set up materials and create textures for the models. After the groom phase wraps up, we'll sync the hair to the material phase for joint review to finalize the look of the asset. For reviews, at every phase and the material look dev process, we've built a project template using geometry nodes along with a small add-on, specifically for exporting review images and the videos. The workflow is pretty straightforward. All we need to do is link the asset collection from our current project to this template. Once linked, the template automatically handles most of the setup, letting us quickly export images and videos for review, like full body and close-up turnaround sheets and turntable videos. This cuts down on the repetitive work of setting up cameras, lighting, or exporting settings for every review, and keeps the output consistent across all assets too. Here's a small demonstration of how the template works. The geometry node modifier generates arrays of the asset. We can tweak distance between columns and rows. Then we can use add-on to fit the camera. And here's a close-up turnaround sheet. For turntables, we have a camera rig that is easy to tweak. And the turning animation and the lightings is already included inside the template. And here is a close-up one. So you'll notice here's another rigging phase. We call it the final rig or advanced rig. This phase only applies to high-level assets. It's not a fresh start. Instead, it builds on and enhances the basic rig we already created. Specifically, we add two main types of improvements. The first is extra automated controls. For example, expanding a complex structure of the robot with only one control instead of tweaking multiple controls at the same time. This not only cuts down the work of making animations, but also better ensures consistent deformations. And the second is the corrective shape keys. These shape keys let us tweak small details of the model, like subtle deformations that the basic rig might not cover. And to help in making the corrective shape keys, we built an add-on. And then here's a brief demo of how the add-on works. First, pick target base rig and select the preset body pose action. You can see an action of many poses assigned to the rig. Then we select a mesh object. A list will expand at a basis shape key to stop the warning. Then you can select the poses to check the deformation and decide if a correction shape key is needed. You can click the checkbox and add a correction shape key, then edit the shape to a desired state. You can use a sculpt or in edit mode. Then after the tweak, you can click the add button, and it will automatically add a driver to the shape key based on the transformation of the bone. You can also right-click on the driver and edit the driver manually, like that. And we can see the shirt is intersecting with the arm. We can repeat the process to fix it quickly. And now you can see, with the help of correction shape key, we can see the intersection is eliminated. So next, the AST phase. The AST refers to asset. It is a destination of the asset pipeline, and the AST files are the actual asset files that are going to be linked into the short file. It will replace the pre-asset mentioned before. While the asset phase is listed at the end of the pipeline, it actually starts updating from the low stage of the modeling phase. Once an asset completes its base rig, the base rig gets updated to its AST file. From there, the AST file is ready to be linked into layout files for short production. As the asset continues to develop, all subsequent details such as materials, hair, and final rigging get gradually updated into this AST file, and importantly, these updates automatically carry over to all the short files that the AST file is linked to. In order to not break file dependencies during the asset updating, we will only maintain one AST file version in most cases. We will only bump the version number if inevitable breaking changes occur. That wraps up our walkthrough of the character asset pipeline. The character pipeline has the most comprehensive set of phases compared to the other asset types. The pipelines for the next two asset types, prop assets and environment assets, are very similar to the character pipeline. So I will be short for these two parts. The main difference between characters and props is that they don't have a separate final rig stage. For props, the basic rig we do in the B-rig phase is already their final rig. And the environment assets are individual static assets, which mean they don't move, so rigging is not necessary for them. For example, the assets you see in this image are the environment assets used in the port scene. So a complete scene like the port showed in the picture is basically made up of a large amount of environment assets. Such scene assembled by the environment assets is also an asset type, which is called set. Later, it will be linked into the short files to be the environment of the scene. And that is a quick overview of the asset pipeline. Now let's shift gears and talk about the short pipeline. In the short pipeline, every phase has its own collection. As these collections move through the pipeline, they come together, thanks to linking and library overrides, to form the short file that's ready for final rendering. Before the deep dive team was established, we already had other 3D departments to collaborate with them with file formats like Alembic and USD for data exchange. Alembic files are read via modifiers on a per-object basis. To speed up the process of loading Alembic caches onto assets, we made an add-on to do such task. Here's a quick demo to give you the impression of how it works. Drag and drop assets from asset library. We have two characters here, for example. Then we library override them into the scene. Okay. And import the Alembic cache directory to the add-on, and click the read button. All available Alembic caches will show up in the list. Refresh the second list, all assets in the blend file will show up. We can point available Alembic caches files to the target assets automatically. And append Alembic caches to the assets, you can see. Then when we adjust the frame range, we can see animations are imported correctly. That. So in the layout phase, we mainly do three things based on the storyboards. First, we place all the necessary assets in the project. Second, we set up camera animation and scene parameters like resolution, frame range, and etc. And third, we create simple animations to outline the movement of each scene element. We also rely heavily on geometry nodes to create visual effect guides. For example, the smoke missile effect you see in this video was created in geometry nodes to show how the missiles move when and how the smoke appears. We create the animation using library override assets. Good old animating. Once the animation is finalized, the shot moves to the VFX phase. There are two phases of VFX. Let's talk about character effects first. In this phase, we mainly handle two things. The first is simulating character claws and hair. And the second one, we're creating effects that interact directly with characters, like the seal effect on one of our main characters' chest. This effect is fully created in geometry nodes, then baked into image sequences and applied as a material texture. This way, the effect becomes software agnostic and can be used across different tools. Beyond that, we also handle some short specific shape adjustments in this phase. Assets in a library or write state can have their shape keys edited directly. To work around this and make non-destructive shape modifications, we built a custom add-on along with geometry nodes. Let me show you a small demo of how it works. Here's a very simple animation. You can see the code intersects with the characters spelled. To fix this, first, we create collections for shape correction. Then create a local object which is identical to the target object and follows its deformation. It is similar to the basis shape key concept-wise. Then we create a clean copy. Create a clean copy of the target object as a frame. We want to do the shape correction. The shape correction can be done by editing the shape object like this. Then we key in the mix slider, can create a smooth mix of the correction shape. Now you can see the code is no longer intersects with the belt. The tool can also correct hair shapes. The process is the same, but with an updated interface, it is more integrated and streamlined. Like you can sculpt the hair and slide. You can see the mixing of the hair, and you key the slider. And now you have a transition of the hair. And now that we've covered the CFX, let's move on to EFX, stands for environmental effects. This phase handles all visual effects that are not exclusively character-focused. Deep Dive has many particle effects, and many of them are done in geometry nodes, like this one you see here. Here's another example to give you more impression about it. In this shot, passengers' soul particles are extracted in a form of rotating triangle halo, stream, and trail. We first generate the base shape of the halos, like this, and then generate the points on them. After add some rotation and attributes, all the points are simulated in a custom node group for particle simulation, like this. You can see the particles are simulated. And with some post-processing, the particle flows are formed. The soul trails are done in hair curves based on the result of the particle flow, and mainly using points to curve node to form the base trail and duplicate hair curves node group to enrich the detail. And using geometry proximity node to get the points near the ceiling and set their position to nearest the ceiling face, instancing field circle shapes and align their rotation to nearest the ceiling face normal, we can quickly get a penetration effect of the particles. Now you can see the result like this. And the crowd phase focuses on creating the behaviors of background characters. Think of the people you see in a busy street, market, and the square. We will be using existing assets and add-ons to streamline the process because there's not too complex about the crowd shots in our production. And here's the shot assembling phase, SAB in short. In many ways, it's similar to the AST phase in our asset pipeline. It's all about bringing key elements together. Once animation and the VFX work are finalized, the corresponding collections from both phases get assembled into a single SAB file. This file will be the foundation for lighting and the rendering. In the lighting phase, alongside the standard lighting setup, we also configure render layers and the passes. Then create a compositing node tree for outputting the multi-layer EXR images. To streamline this process, we've also made an add-on. So here's a common lighting file. As you can see, characters and the environment elements are organized into separate collections. We can use the add-on to create layers like this and populate them with contents like assets, lights, indirect influence, and holdout. For each content type, we can add elements by object and collection. We can also add elements by view layer, which is useful for setting up indirect influence or holdout. We can also configure render passes, shader AOVs, and the light groups for each layer. The add-on has some presets for render passes and the light groups for a quick setup. And it also has some preset layer setups. Just choose the layers you need, and it will do the rest of the settings for you. And just like this, and let's add contents to the layers. And once the layers are set up, we can create layer collections and the view layers to the scene. You can see the view layers are properly configured. Different view layers. And the nodes for exporting OpenEXR sequences also can be set in the compositing editor automatically. The sequences will be exported in their corresponding layer folder. And each passes are denoised. So hit the render, you can see all the passes. And in the folder, they are all organized into their position. Well, that is our brief walkthrough of our pipeline, which is built around Blender as a primary tool. Before my colleague Xiao takes over, let's wrap up by watching the second trailer I said before, produced using this workflow. Enjoy it. Thanks.
The souls penetrate my rays, forgot the way they can, and got a job in the Witness Cemetery. Lighting the coffee by gravity, must refrain from the petition to eternity. Before she smelled it, his extinguished all shining. Before she smelled it, his extinguished all shining.
Hi everyone, I'm back again. I'm about to record the final segment. Today, we are bringing you two fun tools. Let's start with the first one, Storyboard Helper, a storyboarding tool that our directory really loves. I'm sure many of you create storyboard in Blender. We set up camera markers, adjust keyframes at different time intervals, and draw them out. But when you want to edit, you run into a lot of issues. For example, you may only want to edit keyframes, or maybe you want to edit files renamed to follow specific rules, or even place into set folders following those rules. At this point, you can use this tool. The second tool is one I designed called Material Helper. All right, another helper. As the name suggests, it makes working with materials much simpler. Let me simply walk you through its main tool. First, it's auto-update since materials to a specific set browser category. Double-click to edit anytime, or delete them entirely. Second, it supports bidirectional selection. Pick materials by object, or objects by material. It works for objects with multiple materials. Third, we find the 3D material board. Use the eyedropper to pick materials, then the paint bucket to assign them to objects. You can also but pick from the scenes or asset browser. And assign to multiple objects. Plus, there's a short panel for more comfortable operation. In edit mode, assign materials to select faces. Or select faces first, then pick materials with eyedropper. If you find the 3D material board cumbersome, there's an even simpler option: direct dragging and dropping. You can use this in audit mode too. Storyboard helper and material helper that many 3D artists have been wanting for years. We've built them into Blender, and now we are making them available to everyone. They are on my GitHub, and we'll also submit them to Blender Extension platform. Finally, thank you for listening to our talk. It may not be perfect, but we tried our best. Let me end with a line that I think sounds pretty cool. Exploration bears witness to human courage. Open source bears witness to human glory. Thank you, everyone. Have a wonderful day.